Hello, today we are solving problems on empirical molecular formulas, but this problem is different. If in the previous lessons we worked on establishing empirical and molecular formulas through percentage composition, or, for example, through the masses of elements in the composition of a substance, then this task is different. It consists of the fact that you need to calculate the mass fractions or the percentage composition of elements in each of the proposed substances. What is percentage composition? Here, I have specifically shown what it is. This is the ratio of the number of atoms of each chemical element in the formula, multiplied by its relative atomic mass of the given element and related to the relative molecular mass expressed as a percentage. How do they solve such problems? Let's try to do this for two examples. The first example is magnesium sulfate, and the second example is the organic compound nitrobenzene. So how shall we proceed? For the first formula, let's break our calculation into several parts. So the first step, we need to calculate the relative molecular mass for the substance magnesium SO. In this case, we will calculate it based on the periodic table. So for magnesium, it will be 24. Let's round to 1 decimal place, so it's 24. Plus for sulfur is 32. Round it to the nearest whole number. And for oxygen, it's 16, respectively multiplied by 4. The result of the molecular mass is 120. 120, and accordingly, one digit after the decimal point. Now we will calculate the percentage composition. The first element in our formula is magnesium. We make a substitution. For this, the mass of magnesium is 24. We divide by the mass of our substance, 120, and multiply by 100%. It turns out that in this case, the value is 20%. Let's also calculate the percentage composition of sulfur. For this, we divide 32.0 by the same 120 and multiply by 100%. And it turns out that this value will be 26.7%. Now we can calculate the oxygen as well. The calculation can be done in exactly the same way, but I would like to show you how we can find oxygen much more easily. Since the entire composition of the substance is 100%, it is not necessary to perform such a calculation to find oxygen. We can do it more simply. We will subtract 20% from 100%. Magnesium and 26.7% accounted for by sulfur. And then oxygen will account for 53.3%. All right, our calculation for magnesium SU4 is done. Now let's do a similar calculation for the second formula. But it is more complex because it contains more elements. So we will carry out the calculation with precision up to the decimal point. Let's now have 2 decimal places. Depending on the required level of precision, this is usually specified. So let's conduct our calculations to 2 significant decimal places. The substance nitrobenzene C6H5, No2, we calculate in exactly the same way. So for carbon, we will take 12.1. But since we have 6 carbons, we multiply by 6. For hydrogen, let's take the precision as 1.01 multiplied by 5. Next, for nitrogen, the value will be 14.01 multiplied by 1 in this case. And for oxygen, it will be 16. So 0 multiplied by 2. And if we carry out this calculation with such precision, we will get 123.12. Now, let's move on to the percentage composition. We start by calculating the carbon content. So for this, we get 12 and 1 multiplied by 6, which we will divide by 123.12 and multiply by 100%. So this number will be 58.53%. Thus, we switch to hydrogen. For this, 101 multiplied by 5, we divide by 123.12, multiplied by 100%. And in this case, we get 4 whole, 10%. Now we move on to nitrogen. For nitrogen, it will be 14.01 divided by 123.12, multiplied by 100%. For nitrogen, the value obtained is 11.3%, 30%. And for oxygen, let's find it using a simpler calculation. For this, 100% of our substance and all elements are undoubtedly 100%. We subtract our carbon, which is 58, or 53%, subtract hydrogen 4 and 10%, subtract nitrogen 11, 30%, and then oxygen accounts for 25.99%. That's it, the calculation is done. I specifically selected the two solved problems in such a way to demonstrate the level of precision sometimes required in calculations. For example, in the first case, it was 1 decimal place, while in the second calculation, we made it more precise. Therefore, be sure to check how your assignment looks and with what precision you are asked to perform a particular calculation. I hope you understand how to solve such problems. Goodbye.